A very good morning to you all. Today, the topic of signal system we are going to cover is Fourier transform. Fourier transform is a mathematical transform that decomposes a function into its constituent frequencies, such as the expression of a musical chord in terms of volumes and frequencies of its consequent notes. In other words, we can say that both Fourier series and Fourier transform are the mathematical tool for representing signal in frequency domain. So as we know that Fourier series is only applicable to periodic signals, and similarly Fourier transform is also applicable to to periodic signals also, as well as these both use as these both Fourier series as well as Fourier transform are the mathematical tools which is used to represent signal in frequency domain. Okay, the domain we use here is on the basis of frequency. Fourier series mainly used for periodic signals. Fourier transform is used for periodic signals. It is also used for periodic signal, as I mentioned you earlier. There are some conditions for Fourier transform as we studied in here for Fourier series. There are similar conditions for this also, and these conditions are necessary because if you don't if the signal then does not specify the specific condition, then we can't find the Fourier transform. So first one is that is f of t should be absolutely integrable, that is the limit minus infinity to infinity f of t dt is less than infinity, means it should be integral as well as it should be also finite. The value should not exceed from infinity. It should always less than infinity, I mean. Okay, the second is the function must have finite number of maximas and minima. This condition is similar to the Fourier series, that there should be a maximum number of minima and finite number of maximas and minima in a given signal, otherwise the signal will become um, non-periodic for this. So we cannot find even though the signal is periodic, but we are not able to find the Fourier transform for that specific signal. The third condition is the function must have finite number of discontinuities. It means if a signal has more than matlab, you cannot able to count the number of discontinuities, then the signal we cannot find the Fourier transform of that signal. Okay, then there should be a finite number of discontinuities if you want to find the Fourier transform. So these are the three conditions for Fourier transform. Next is the representation, how you represent the signal, that is x of t is equal to x of j omega. We always, if you have any signal in time domain and you have to change the domain into frequency, and this will be the Fourier transform that signal, you can represent it as capital X bracket of j of omega, that is radian per second, or you can write it as x of f. The frequency, the domain will be changed from time to frequency. So this is a Fourier transform of that signal. It is a complex function because it has a specific magnitude as well as it has a specific angle for Fourier transform. And the formulas we are going to study here, there are two major formulas for Fourier transform. That is, first one is x of t is equal to, we know x of j omega. So we can write x of j omega is equal to minus infinity to infinity in terms of time domain, x of t into x of minus j omega t d of t dt. So this is a general formula for Fourier transform. So whenever we have to drive any question, so you have to recall this formula, that is minus infinity to infinity x of t into e raised to minus j omega t dt. And this is in terms of Fourier transform. In terms of frequency domain. The second formula is x of j omega in terms of time domain. Now you have to mention it. So x of t is equal to 1 by 2 pi minus or infinity to infinity x of j omega dot e raised to a j omega t d omega. This is known as inverse Fourier transform. The above formula is for Fourier transform, and this one is inverse Fourier transform. We study these two, both the topics and their examples in the next video in detail. And the combination of these two formula is known as Fourier transform. Thank you.